So the next thing that we need to talk about when we're talking about forecasting is the how do we actually determine how good a model is? So we want to evaluate the performance of each forecasting method or model that we come up with. So the most common way to do this is to look at historical forecast errors. The forecast errors are simply the difference between the actual and the forecast. So here I'm defining them as E sub t, so the error term at time period index t is equal to the actual value of the dependent variable, the outcome variable, y sub t, minus what we predicted. Remember, y hat is the prediction. So if we have a forecast for 12 different months and the actuals for 12 months, then we can calculate the error terms, and then we're going to do something with those error terms. So for example, the different common metrics that we see often are mean absolute deviation, MAD. Sometimes people call this mean absolute error. I like the acronym MAD a little bit better. And then we have mean absolute percent error, the MAPE. There's mean squared error, MSE, and then the root mean squared error, RMSE. So we'll look at each one of these and talk about advantages and disadvantages. So the mean absolute deviation, the MAD, averages the absolute values of the differences of the forecasted values from the actual values. So it takes the absolute values of the error terms, adds them all up, divides by how many of those error terms we have. So now the question is, why do you think we're taking absolute value? Well, hopefully you're saying to yourself, well, I don't want the negatives and positives to cancel each other out. So here we're more interested in how far away we are from the actual. We're not as concerned about the direction. There are times when we are very concerned about the direction, but in this case, this metric will not capture that. Instead, it will capture the magnitude of how far away we are from the actual. Then we have the MAPE, the mean absolute percent error. It takes the absolute value of the error term, divides by its actual, and then adds all those up, and then divides it by how many of those error terms that we have. So this is taking a relative approach to it. So in the MAD was absolute, and it was the actual values that we were looking at. So the units back on MAD would be whatever units Y was measured in. Here we're dividing the error term, which is in units that Y was measured in, divided by Y, which has its units it was measured in. So the units cancel out, so we come up often with a percentage error. So this number will be between 0 and 1, and then we often convert it to a percentage. I prefer, when I'm calculating these in Excel, to leave it as a decimal but format the cells as percentage. And then many people like this one because they think it's the most intuitive. And why do you think that is? Well, many managers and many people in general can understand percentages. So this will say if a MAPE is 2.7%, you can say on average our forecasts are off by 2.5%. Now again, we're not saying whether it's above or below, but just on average over all the historical stuff that we've looked at. And then we have the mean squared error as the third metric. It averages the squared differences of the forecasted values from the actual. So it takes the error terms, squares it, adds all those squares up, and then divides by how many we have. This looks at the total magnitude, and because we're squaring it, it gives greater weight to larger deviations. When you take a number that's larger than 1 and square it, the number gets big pretty quick. When you square a number that's between 0 and 1, it actually gets smaller. So here we are weighting things more towards when the forecast is farther away. So we're giving larger forecast errors proportionally more weight than smaller ones. Now the problem with this metric is that the resulting units will be whatever we measured Y in. So if it's sales, it would be sales squared. That's kind of hard to interpret. So to get around this, the last metric is the root mean squared error. So this takes the positive square root of the MSE and it gets us back into the same units as the variable measured. So this is often a good measure to use as well, and one that many people do use. So the comparison of the different accuracy, the MAD calculation and the MAPE calculation are very similar. One's absolute in magnitude, in terms of magnitude, that's the MAD, and the other is relative, so it gives us a percentage, that's the MAPE. Sometimes MAPE is actually reserved for comparisons in which the magnitudes of the two cases are different, and this could be even different units that we're measuring stuff in, so that we can say, so if we're measuring sales of actual individual units versus sales of crates of something, like at a grocery store, instead of individual cans of tomato soup, if we're measuring, packs of tomato soup come in packs of 18 or whatever, then we might want to look at MAPE to look at percentages between those two.